Hello, everyone. My name is Vint Cerf. I'm one of the members of the Interplanetary Networking Special Interest Group Board. I was one of the founders of IPNSIG back in the day. And it's my pleasure to introduce our chairman, Yosuke Kaneko, who currently serves as our chairperson of the Interplanetary Network Special Interest Group of the Internet Society. It's an international nonprofit organization that envisions expanding network to interplanetary space. He's leading efforts towards creating a common vision and shaping the future of an interplanetary network. With his engineering background in avionics and communication, he has about 20 years of experience in the space field. At the National Space Agency in Japan, JAXA, he has contributed to the development and operation of the International Space Station, including establishing a bidirectional communication link using the Internet protocol between the ISS and the Japanese ground system. He also led the Japanese flight control team as flight director between 2009 and 2010. From April 2020 to March 2022, he had served at the Strategic Planning and Management Department of JAXA, where he had led the overall coordination of JAXA's human spaceflight, space science, and exploration programs. Today, he currently serves at the Space Exploration Innovation Hub Center to promote research and development of innovative technology with non-space private sectors to enable future space explorations. It's my pleasure and honor to introduce Yosuke Kaneko. Kaneko, you have the floor.
Okay, thank you, Vint, for the kind introduction, and good morning, good afternoon, and good evening to you all. I'm Yosuke Kaneko, and I would really like to start by thanking everyone for your participation to this inaugural event of the IPNSIG Academy. And I can't really stress enough on how excited I am to deliver this first keynote today. So again, thank you so much for your participation. And for the first round of the Academy, I will be talking about the 100 years vision toward the solar system internet. And it's really my hope that this 45-minute session will become some kind of an opportunity for all of us to reflect upon ourselves on our exciting future ahead. So I know there are people with many backgrounds participating today, and I'll be talking for the next 20 minutes or so. And I would like to use the rest of the time for discussions and Q&As. Has everyone ever imagined something like an interplanetary network before? When we do this kind of events online, we really don't see any hands up or screaming, but it makes me super excited when I see some sort of a network that would scale up to the size of a solar system or even at the scale of the universe. But one thing that's clear to me is that communication is really an infrastructure that would support the human and robotic activity as our social and economic sphere expands into space. Although we really don't know what the scale of this network would expand over time, but I would really like to start by looking into our future for about the next 100 years or so. At the IPNSIG, our goal is to expand networking to interplanetary space for the benefit of humanity. And along these lines, the IPNSIG is working toward to create a common vision of IPN with the various stakeholders and to offer a narrative and roadmap that would enable the development and evolution of the IPN, and also to promote the use of DTN technology, which is the delay and disruption tolerant networking protocol, which is one of the critical technologies to conduct communication at interplanetary distances. And the IPNSIG logo that you see here, it really represents our goal and endeavors toward the realization of an interplanetary network. And in order to realize such a long-term endeavor, our generations alone could not achieve such goal of creating an interplanetary network. And that is exactly why we're setting up the IPNSIG Academy. The Academy will become the venue to nurture the knowledge and expert that would pave our way forward to realize the IPN. It's our intent that this effort to be continued and conveyed to our next generations and onto our next generations, since those future generations will eventually become the real engines of making IPN. There are multiple facets that we might want to be aware of in order to achieve an IPN. And it's really not just about technology, We might also want to put our eyes on policies and also on governance issues. So for this year, we've invited the most prestigious speakers around the globe to provide a series of talks covering the multifacets of IPN. And at the very last session, we will be setting up a workshop where we will be having some interactive discussions on architecture and governance with our Academy participants. Make sure you sign up for all these keynotes and stay tuned for all oncoming announcements on our website. Okay, so let's start talking about our future. I really want to start with where we are today in terms of communication architecture. We have several missions going to the moon and Mars and farther beyond to other planets within our solar system. The communication is basically done in a point-to-point fashion. We talk to a given spacecraft to control it and get the data down. Basically, it's simply as that. And when we put our eyes around the globe, what we're really seeing here today is that the many private companies and nations are providing significant efforts in space communications, and more industry, more nations are emerging and are bringing in their architecture concepts into space. So there's a significant amount of thrust that's really pushing the horizon of space communications. And I just find this truly amazing. Fast forwarding a little bit to the 2050s, we might have a commercial space station in low Earth orbit, maybe a lunar base and perhaps a Mars base, and several spacecrafts orbiting the moon and Mars. So it's conceivable to me that we might have an Earth, lunar, Mars network backbone supporting the various activities and infrastructure in each planetary domain. We go even farther into the 2100s, we might end up that might look like this. This is a notional picture that was crafted a little while ago, but it gives you a sense of what a solar system internet or SSI would look like. The red hexagon-like lines in the middle of the picture is an illustration of a network backbone of the SSI relaying data across our solar system and even for deep space. Although this is not the solar system internet that we might be building, what IPNSIG envisions is a common network backbone that enables science and exploration and commercial activities and could even support our normal daily lives. So the solar system internet is kind of rather a concept of networking the planets or networking the things and humans at an interplanetary scale. That's what we've envisioned on how the SSI network might grow or scale over time. And then we started to ask ourselves, what might be the issues that confronts us in order to realize such an SSI? Or are there any lessons we can learn from the evolution of the internet? Or how might the SSI evolve over time, considering that we have various players in the space arena today? What could be the key properties that might support that evolution? In order to give a thought to these questions, a group called the Strategy Working Group was formulated, and Vint was also part of this. And after several intense discussions at the working group, the IPNSIG has publicized a report last year titled A Strategy Toward a Solar System Internet for Humanity. And I will try to touch a little bit on what we've said in that report. And it's also downloadable from our website. So I appreciate if you can check that out. First, we try to look toward the future on how the solar system internet architecture could change over time. And here's what we said that might possibly happen. So starting from the left, today, the government and the space agencies develop and sustain the network backbone. And some of the commercial users are using that infrastructure. This is where we are today. But maybe 30 years from now, the architecture could evolve to a state where the government and commercial and academic backbones coexist and even have the capability of interconnecting together, similar to the peering concept in our internet environment. Even in 100 years from now, we may have a commercial sector primarily running their own backbones to serve multiple users. But we also think that there still might be a dedicated backbone serving for government and also for academic purposes. So this is what we thought would naturally happen when we look beyond 30 to 100 years. So then we started to ask ourselves, what are the significant properties or the principles we need to pay attention to in order to support the evolution of the solar system internet? So we've laid out 7 key properties that you can see in this bubble chart. The first one would be collaboration. And of course, we need collaboration to realize SSI. The IPNSIG sees the solar system internet as a common structure for all humankind. And we try to build it as a common system. Understanding the investments made by various players today will become mutually beneficial in the long term. And global standards. Having a unified global standard is also crucial to establishing an SSI as a common structure. The internet became so successful because there was a single source of doing things, such as the TCP/IP and BGP and so on. So the single technical standard that's open and free and accessible for everyone is really the key to make SSI a reality. One of the key technologies to allow deep space communications at interplanetary distance is the use of the delay and disruption tolerant networking protocol, the DTN. And you will be hearing more about this technology from the other speakers at the Academy, but it's really a critical piece of technology to make SSI real. Global standards will be extremely important to interconnect the various networks and make them interoperable. And at the same time, having a global standard would also enable innovation. And it's also a very important part as well. So stability, this part was intended to have a tie with the standards part, where we should avoid having standards rapidly changing or not becoming backward compatible. So stability of a standard is important to sustain the robustness of the SSI infrastructure. Democracy, we should also accept the concept of a democratic approach to construct the SSI, which basically means that any entity who would wish to join the SSI would have the freedom to do that. No single actor should direct configurations for the SSI, and the SSI should naturally evolve while accepting the minimum governance that is required to preserve the coherence of the overall architecture. So democracy is very important. Affordability, the SSI must be affordable to its users. Affordability is a key aspect, but it could have a different meaning to each of the stakeholders. For instance, for a commercial entity, it's important that the development cost of a given product will need to be recovered, perhaps by providing some networking services to its end users. And for the case of an academic entity, the cost incurred to use the network must balance with the expected science outcomes produced. So the term affordability does not necessarily mean that it's cheap, but rather that the costs incurred must be paid for. Expandability to scale up and add new functionalities, and expanding the network topology is important. When we look at expandability, this also implies to us that the architecture must be flexible enough so that new technologies can be adopted during its evolution. We must acknowledge that flexibility enables expandability. And it's important that this feature is recognized from the early phase of the SSI development. So last but not least, security. We did talk about the democratic approach of allowing freedom to join, but at the same time, it's also critical that the architecture is capable of securing the information that it carries for a safe and secure use of the network. So security is an important factor. Those are the 7 key properties we have laid out that might support the development and evolution of the solar system internet. Again, the IPNSIG really believes that the SSI should be built as a common structure that benefits humanity. And we believe that the very first step is to come up with a shared vision toward a common SSI and recognize the value it may create. We also think that the concept of co-creation with the public and private sector is also indispensable. And if we're successful with sharing of vision and co-creation, we should naturally end up in a coherent SSI architecture. Here, I would like to touch upon some of the initial steps, I would say, that we have laid out toward realizing SSI. These are a set of activities that the IPNSIG has proposed in the report in order to make some progress in the near term. The first pillar, it is about testing DTN at scale. What we're hoping to do is to have DTN embedded in some terrestrial systems, create a significant amount of traffic on Earth to test the overall performance of the DTN protocol. This is an effort that would enable us to refine the technology to adopt it to a more scaled SSI network. The second pillar is to test the interoperability between the various implementations of the DTN. And the third would be about promoting DTN. We believe by increasing exposure of this technology will contribute to more investment and adoption of this technology to operational implementations. And we also understand that one of the success stories of the internet was the founding of the Interop exhibition. So it might make sense to explore setting up a similar exhibition to draw more attention from the government and also from the commercial sector as well. And the fourth pillar is about deploying experimental and active missions to demonstrate this technology in space. And the fifth pillar is to explore a well-functioning and healthy governance model that would support the development and evolution of the SSI. The IPNSIG has recently set up an architecture and governance working group to specifically tackle this issue. Hopefully, we'll be able to share some progress with you sometime later. Our sixth pillar is to instill our vision and to convey it to our future generation. And that is exactly what we're trying to accomplish at the IPNSIG Academy. We're gradually coming to an end, but I just really want to re-emphasize that our young generations and our future generations will really become the impetus on realizing IPN. And it's really my hope that we continue this effort as long as we can and try to create a common infrastructure that would benefit all humanity. And that brings us to our final page. The presentation materials I have shown you today are available at our website, shown on the upper left corner. And please drop us a note on any questions or comments to our secretariat address, which is on the far right-hand side. With that, I would like to conclude my keynote, and thank you so much for your attention. Back to you, Vint.
Thanks so much, Kaneko. I did notice that there are some questions in the chat. First one comes from Subramanian Muthaswamy. His question is, this 100-year vision, what components are in this vision? For example, could there be a space mission relevant knowledge cache in one or more space stations for quicker access by cosmonauts on space at a latency distance of hours or more? So the idea is distribute information, physics, to make sure that the people who are relying on the system have access to information without delay. So I'll let you tackle that one, Kaneko.
Okay, yeah, the 100 years vision is like a concept for us. If you're talking about spacecrafts and hardware, I would say that it's going to be a progression of development. We will start from near Earth and then gradually expand to the lunar domain and then to the Mars domain and to following planetary domain as well. As we grow our network, our intent is to have and set up a common network backbone that could be commonly used for various purposes. That could be for government or for commercial or for academic purposes. So that's what when we say 100 years vision, we're talking really about the network backbone here. What we're trying to address at the IPNSIG is, what I've spoken in my chart was that when we talk about architecture, there's also a topic on governance. And we're seeing a lot of emerging concepts provided and proposed by various entities today. We are trying to figure out a way to make this whole architecture concepts to work as a whole. And what are the governance mechanisms that could support that architecture? So those are some of the relevant discussions we are having within our group.
Thanks so much, Kaneko. Steve asks one other question. In the near term, what about floating a few communication mini satellites in the most relevant orbits so they might be useful for missions to the moon, Mars, and maybe the day trips, Virgin Space or SpaceX? That sounds like a pretty reasonable idea to me, and probably be part of a normal practice to begin getting Earth, Moon, and Mars communication in place. But I guess that's for you to respond to.
Yes, of course. I think there's a various architecture that could emerge into the SSI architecture. And I'm starting small with the CubeSats, and providing relay services to a certain domain would really absolutely make sense to serve for a mission. And then the smaller network can grow gradually to a bigger one and eventually become a backbone.
Alberto Montilla asks, thanks for the keynote. In your perspective, how can space agencies and governments contribute to accelerate the development of the solar system internet?
Very good question. I would say that the architecture itself is a product of the space agency or the private sectors that are proposing that architecture. As I've said, since we're seeing many emerging architecture concepts provided by many entities in space communication. So the IPNSIG's job is really to figure out some clues to make them work all together as a common system and find any governance issues that needs to be resolved in order to support that architecture. And it's really my hope that the space agencies and private sectors would incorporate what was discussed at the IPNSIG and at the Academy and endeavor to reflect them into their own architecture design, because by doing so, that would really ultimately lead to realizing a common network backbone.
There is a question from Ahmed Matawi who says, can you provide us with tutorials or courses of DTN and IPN? That's what the Academy is about.
That's about the Academy is all about, actually. And there is going to be a few talks around DTN. I think, Ben, you are going to be up next for the Academy. It's about the overview of the DTN and the conceptual differences with TCP/IP. And then there are some ongoing projects that are going on within the IPNSIG by the Pilot Project Working Group. So some of our members will be addressing you with some of the project works using DTN. So the answer is yes. And I think there's a link on our website that directs you to some tutorial video showing you the basics of how DTN works and et cetera.
Modio asks the question, what are the challenges that you see in converging on a common set of standards?
That's a hard question. I think, first of all, as I've said, before even we talk about standards, I think we should really share the vision of IPN, what the value it could create by having this infrastructure. I think that's the very first step before we even talk about standards and the key principles that I've addressed. So if we can come up on the same page regarding this high level part, then I think we could move smoothly into the standards discussion. Unfortunately, I'm not really directly involved in the standards development. Maybe, Vint, if you have any comments on the standard.
We have two places where the standards have been developed. One is the Consultative Committee on Space Data Systems, and the other is the Internet Engineering Task Force. Many of the people who have worked on the development of the bundle protocols, which are bundle protocol suite is the basic set of delay and disruption tolerant networking protocols that have been developed. And those people are also people who have worked on and are continuing to work on the standards making efforts at CCSDS and at the IETF. So the net result, no pun intended, is that there's been a substantial amount of cooperation, collaboration, and coherence in the development of these protocols. And now, of course, a lot of effort to make this source code available in many cases, and certainly to enable testing of different implementations to verify that they are interoperable. So there's a lot going on in order to facilitate the standards development and the ability to demonstrate that the standards are both fit for purpose and able to work. Patrick Ryan says, do we need to wait 100 years until the academics and civil society come into the picture? Actually, if you look at the picture, Kaneko, didn't we show that the academic and the private sector actually get into the picture fairly early on during the next 20-year period, and they might drift away when most of the effort is commercialized, but they might have their own still persisting special purpose nets. But Patrick, we expect the commercial sector and the private sector, civil society and academics to be part of this story early on, not 100 years from now.
Yeah, and just to add a little bit to that, we're having the Artemis program propelling us to move farther into lunar and to the Mars domain. And this big, gigantic program is already starting. And relevant to communication, things are really moving much more faster than I've depicted in the picture. So I would say it might be earlier than 30 years from now that we might have a commercial entity providing relay services or academic entities providing their own network and kind of coexisting each other with the government network. So things are going to be happening probably a little bit earlier than expected. So yeah, it's coming maybe in 20 years or something, but it's going to be coming.
Siva asks another question. I'm going to paraphrase because it's fairly long, but his idea was what if we had a reporter in a board transmitting half of a file by the DTN bundle protocols and then the rest of it a little bit later, just to demonstrate the resilience of the system. I don't know whether we need to go that far. We might be able to do this as part of our normal testing in the terrestrial networks. Did you want to add to that?
I believe so. I think we can do that in our terrestrial, something to look at on the ground, maybe.
So Rob Broom asks, has any thought been given as to how any error correction protocols might operate under the DTN?
I don't have the answer to that. Do you know?
Sure. For one thing, at the layer below the bundle protocol, where we get the Licklider transmission protocol or another link layer, it's not uncommon to do forward error correction in order to deal with the fact that these transmissions are taking place over very long distances and errors could be very common. So the answer is absolutely yes, Rob. We will do that and have done that. Terry has a question. I'm a building architect involved with NASA technology transfers since 1979 with Dave Nagel and others. Next now, Doug Engelbart at Stanford, Space Industries, and so on. If you're encouraging participation of those wishing to participate and contribute to the Academy, could you speak to how to be involved with the Academy or email me later? And we'll keep Terry's email address here. I'll make sure that we copy it. But what's your advice for people who want to be involved in the Academy?
Yes, we are most welcome for those proposals. Thank you so much for saying that. As you see in this chart that's projected right now, you can just send us a message at the Secretariat address on how you might be able to take part in the Academy, and our Secretariat or myself will directly respond back to you. So thank you very much for saying that.
Jorge says, do you think that companies like SpaceX will adhere to the standards?
That's a very good question. I think it's a difficult question, but I think we should try because, as I've said, it's our really aspirations to make something common for humanity. So I think we should try to have everyone adopt a single standard, regardless of SpaceX or Amazon or whomever that would provide any knowledge or any component to the architecture. So we would like to try to do that in order to facilitate a common infrastructure.
A related question from Claes Mogren, is there some kind of DTN compliance checklist for RFC 9171, which is bundle pool number 7, or a test server that developers can connect to verify their implementation?
Vid, do you know any of the things that was raised in the question, the checklist? And
the answer is we need to develop that. And so if there are any volunteers that'd like to help us with that, we welcome them. But that's part of the project development activity, which is to test a lot of these things and to do a standard way of helping people verify that their implementations actually function as they should. Siva asks, why should it take 30 years to form a commercial IPN entity? Could it happen today with a creative investment model, reward design, and even indirect revenue model?
Good question. We just said it was 30 years, but it's really our hope to formulate something that would push us forward that involves the commercial and government and academic to start this thing as soon as possible. It's our wish, but in the report, we just said 30 years is something that might happen in the long term. Yes, I'd like to see it working as early as possible, but 30 years was just like a criteria for us that we said in the report.
Siva asks, could IPN make, as part of its work, to do research on quantum communication and quantum computing technologies with a view to work on problem areas like latency?
The IPNSIG is really focused on the delay and disruption tolerant protocol, but I think we actually need to collaborate with other technologies, as you say, the quantum computing and maybe enough cloud computing, maybe in AI and other things. It's not the real core of what we do, but I think there's going to be some interactions with other organizations that would really push us forward about making this real.
Well, I'd like to add a response to Siva's question because a lot of people have the belief that somehow or other entanglement allows us to communicate faster than the speed of light because we know that entangled particles interact with each other without any sensitivity to the distance they are apart. The problem with that is that the entanglement is not communication, first of all. It's certainly a kind of correlation, but it is not the same as communication. What happens is that if you have two entangled particles and you separate them like two photons, first of all, it may take speed of light delay to get the second photon to wherever it is you want it to go. And then the only thing you can do is to measure the state of the one that stayed behind. And when you measure it, then you know exactly what the state of the other one is. But that's not the same as setting it to a particular state so the other guy gets a signal. So this is, unfortunately, it's not signaling. Maybe we'll learn more about quantum communication as we explore that territory, but at the moment, it doesn't help us with the speed of light delay, I'm sorry to say. I think that's all of the questions that have been asked so far. Let me just ask you to reprise the Academy. It's going to go on for not just this year, but also into 2023. Is that correct?
So that is correct. Thank you, Vint. So that takes us to our program for 2022 and 2023. Just a quick announcement on future Academy talks. We will have a series of talks, as you can see, and you will be up on stage next time on June 1st, and we'll be hearing a lot from Vint on DTN and a lot more on DTN following talks in SSI architecture. We're also going to cover NASA's plans on LunaNet and ESA's Moonlight overview, some standardization efforts from IETF and CCSDS. Some governance issues are also going to be covered, and space policies and around governance as well. And our final will be on the 12th line, which will be the workshop discussing about architecture and governance. Please make sure you all register yourself. And if you wish to become a member of the IPNSIG, just please drop us a note to membership@ipnsig.org, and our secretariat would be happy to address you. And that's all I have to say here. So back to you, Vint.
Well, thank you so much, Kaneko, for your leadership and for the opening of the IPNSIG Academy. I'm looking forward to the other programs that will take place during the rest of this year and next year. And we look forward to seeing you on June 1st.
Yeah. All right. See you
Bye
guys.
now.
Bye-bye.